Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. Today, we have a post on exploiting CRLF injection with hop-by-hop headers, an info disclosure and GitHub security advisor functionality, and more. So, yeah, we'll jump into the hop-by-hop header topic first, and Z, I'll let you take this one away.
Yeah, and this was a post, actually. I saw this last week, and at a glance, since I ended up seeing a lot of posts, I looked here, and it ends with, I wasn't able to successfully chain this vulnerability with others. So I'm like, oh, it's just like an idea, and I skipped over it, but I ended up coming back to this. It actually does have a kind of cool technique here, or I guess trick for taking what might be an apparently non-exploitable issue. So it is a CRLF injection. So normally when you have that, you would, or you could, there are various ways you could try and exploit, but one of the common methods is you do a double new line injection, so like the RN, and then you start on the body of the response. So what you'd end up in that situation is you control what the response body contains, so you can put like your XSS payload or whatever you want in there. But that doesn't work when you have it in the location header, because what you end up with there is the browser goes, oh, we're redirecting, so it doesn't even render the body, so you can't get you can't get that XSS payload to run. So they were able to abuse the hop by hop headers or the connection header. So a hop by hop header is just headers that get added by, say, one reverse proxy meant to be processed by another proxy in the chain that aren't supposed to make it all the way. In this case, it's it's on the way out, so it's not supposed to make its way all the way to the end user. It could also happen in the other direction, going into the target or backend system. And what you would do with those is you add those headers, and then in the connection header, you would just include the name of that header, and that just tells the proxy, hey, this is a hop by hop header, so remove it before passing this along. Like, after you've done your processing, get rid of this header. So they just went, took that header, and said, hey, the location header, that is absolutely hop by hop. Just remove it. You don't need it anymore. And by including this connection location as part of their injection, so using the injection, they injected the connection header, put location in there, telling it drop the location header. Now it's no longer redirected. It's still in HTTP 302. So in theory, it's supposed to be a redirect, but without the location header, browsers will render the page, giving them the XSS. So I thought it was a cool trick. I actually remember years ago, before I even had much of an awareness of the hop by hop headers and doing this, I remember being in this exact situation and not being able to exploit this issue very well. I did have some little like JavaScript URL thing, if I remember correctly, was kind of the solution I went with just to show something, but yeah, that's not a very effective exploitation trick. So I really like the solution, and I like seeing the abuse of these hop by hop headers, because I think that is kind of a newer or more recent area of research, seeing people abusing those in different ways. We've seen it with request smuggling being used there to either create a request smuggling or do something with that. So it's interesting to see the application of that, because it is a functionality of HTTP that it isn't intuitive and isn't necessarily obvious unless you've kind of dug into it a bit.
Yeah, I mean, hop by hop in general is just really difficult to keep track of and manage. It causes a lot of vulnerabilities and like networking stacks too, because it's just so tricky to deal with. So it's not surprising it can be abused in this way, more on like the web, like HTTP side too. So yeah, like you said, I thought it was a cool trick, and I'm sure there's others that would probably end up in similar situations that could use it. So something handy to know for sure. All right, so we'll get into our next topic, which is a HubSpot account takeover, which HubSpot is like a customer relationship management platform, or CRM, which has a bounty program on BugCrowd. And yeah, so I'm going to jump through a lot of this post, because a lot of this post is like trying different things and then finding out they don't work. It like keeps baiting you a little bit.
Yeah,
But
like this post felt a lot like, here's everything I tested for. I don't know. I mean, I oftentimes like seeing the posts that include like their failures. This one though,
it's
it
a
did
little bit too
feel,
over-explained, though.
yeah, this the way they went about this, like when it's failures in terms of like the dead ends or rabbit holes you go down, great. this I feel like they could have just summarized with like their test case list and been like, didn't work, rather than explaining everything here. I don't know. That's me. But I'm very focused on the vulns. I'm sure somebody could learn out of this too. So
Yeah. So getting into what did end up working, what the vulnerability was they noticed that if you passed an href parameter, which so it's in the password reset functionality. I should have said that earlier. I kind of skipped over that. So that's where he initially started investigating, found this login portal, noticed the password reset functionality. It's a pretty, it's one of the first places you go to when you're looking for bugs. And the flow is as you would expect. You enter an email, send a clickable link to it with a token or whatever for the password reset. Now, what they noticed was that when they tampered with the request for that password reset, if they passed an href parameter in, it would get used to construct the link that would the clickable link that would be sent to the email, and that seemingly wasn't validated. So, as an attacker, you could just send a password reset request on behalf of a victim account and set the link to point to a server that you control, and then you'd be able to MITM or capture the token or registration number that would be passed into that link. So it was kind of a weird flow. I'm not really sure why it would take an untrusted href and use it to build the link like that.
it is
It's a little bit weird.
It is a hidden functionality, so they did have to do a little bit of brute force to actually discover
They
the
did,
fact
yeah.
there was the href parameter. My feeling there is it's probably some that developers were using in testing. They'd maybe just want to pass in the HubSpot.local domain or something for them just to test with, and they had this very overpowered functionality in there that really shouldn't exist and really shouldn't be left in when it hits production, but it was in this case. That would be my guess, is it either came from that, or I could imagine some sort of legacy system, adding in the param value and needing to filter there. I don't know how likely that one would be. I feel like developers probably the more likely scenario here. But yeah,
It
it's
could be,
functionality that
yeah.
really shouldn't exist. There's no reason to allow an attacker to have control over the base of the password reset link.
That's a fair shout, actually. Some sort of debugging backdoor like that. Yeah, that would make sense. But other than that, in a regular a standard authentication flow, that's really weird. So yeah.
I mean, even with that, it would be better to use something like an environment variable, something that isn't attacker controlled with that. Put in the environment default to the production domain. So, a dev can run an instance that does something different without exposing any sort of, or accidentally exposing this sort of dangerous functionality.
Yeah.
I will also kind of shout out here that the author makes one kind of claim that, I don't know, it leads to a sentiment I see pretty often, but I'm not a fan of. And I'm just trying to find the exact quote here. I should have looked this up beforehand.
I think I just saw where you had it. Let me yeah.
Here we go. Makes the golden advice that don't rely on tools if you don't know what the tool is doing in the background. And he's making this claim because when he initially did the scan trying to find parameters using Arjun, it didn't find this href parameter, and that just had to do with how it would generate the values, how it would tag them using a number appended on. So then effectively it would always make the email here invalid. So they couldn't test any other parameters going on there. It would just kind of get stuck there. And I don't know, the sentiment that you need to understand exactly how every tool works is something I see a lot when people are talking about oh, don't be a script kiddie. You've got to understand all of this. And I just don't think it's practical these days. I do agree that having enough knowledge over here's what it's doing so that you could debug it like they had to in this case, and doing sanity checks on your tool. So they knew it should be finding some of these parameters that they know about. So, when it doesn't, they know to go look into it and they can figure out what the problem was. But I don't think before you can ever use Arjun, you have to understand exactly how it's taking every value and does that check. I think that's something you could learn when you actually run into an issue. It can help to have deeper understandings of your tools, but I don't think it's necessary to understand every tool before you ever use it. Because part of why people release tools is so you don't have to do that same level of digging that they did. It's so you can build off of their work, not redo their work. Um, it's like, how many of you understand everything about, using burp or whatever? Like, you might have a reasonable understanding, but not necessarily everything. So, I don't know. It's a sentiment I see a lot, and a lot of people toss out there that I just want to mention that I definitely disagree with. I think having an understanding is important, but it's not essential to using every tool.
Sorry if a phone ring came through there, by the way.
I
I
don't
tried to
think
mute my
anything
phone.
came through.
Oh, okay, good. Uh, so that won't confuse anybody. Yeah, the way I'd put it is it would be ideal if you would understand like what the tool is doing at a like lower level, I guess. But yeah, putting it as like a requirement, I kind of disagree on that too. Because like you said, like the point of the tooling is to, abstract some of that away from you and also, cover the implementation details. So having to know how it's implemented is kind of defeats the purpose a little bit. But yeah, I mean, there is some, fair point to it though. Like it will help you understand things if you know what's going on under the hood. So that's why I say it would be ideal, but yeah, it shouldn't be required.
Yeah, you're more effective when you understand exactly what your tools are doing and, that low level. That's absolutely true, but you don't need to reach that level of understanding before you get started. I'm a big fan of learning as you go, not wasting time like sitting there needing to learn everything before you get started. I feel like a lot of people get trapped in, well, I don't understand this, or this, therefore I'm not ready to start, and hold themselves back. And I think this sentiment is doing exactly that. It's holding people back.
Yeah. All right, so we'll get into our next post by Ophion Security, and it's about an information disclosure in GitHub through the security advisory feature, which is always fun to see security features being turned around on the target. So the bit of background here is that GitHub allows maintainers to draft a public security advisory, which we've covered quite a few of in the lifetime of this podcast. And in doing so, you can create like a temporary private fork for trying to collaborate on a fix and review it and everything before disclosing it. That way you're not publicly dropping an O-Day. And in November, they added the ability for orgs to allow external users to report vulns to their public repos. And in this case, the external reporter is added as a collaborator to the vuln report. They get some special permissions to be able to comment on it and accept credit for it. And on the private fork, they're also added as a collaborator to the repository, though with some limited access. So, like things like issues, downloads, projects, and the GitHub Actions and CI/CD stuff were off limits. What they ended up finding, though, was that the code space feature was still enabled for people that were pulled in on the private fork. And for those not familiar with code space, and I don't really use it either, I had to look into it a little bit. It's basically a cloud hosted dev environment that you can use for like collaboration. It's ran in the cloud on a VM and whatnot. And you can run like VS Code and a few other different editors and environments in there. But what's important is that Codespace has this, sister project called Codespace Secrets. That way, in the div environment, you can access like API keys, SSH keys, tokens, anything, any like kinds of secrets like that. And those can be scoped to like the org, the repository, or personal use. And the problem there is an attacker can basically utilize their access through the private fork to access the code space. And they can exfil these secrets from the environment by literally just running the end command inside of the code space terminal. So it's just kind of an overlooked functionality, giving somebody that was given access to private fork a little bit too much access. So yeah, it was a bit of an interesting flow. It's something that you'd really have to think about and be looking for. But it's pretty impactful because they actually show that this could be escalated to attacking GitHub itself. Because near the end, they mentioned that GitHub's enterprise importer repo has this external vuln reporting functionality enabled. So if if an attacker tried to abuse this chain or like issue on that repo, they'd be able to dump GitHub secrets such as the Go proxy token, which could give you access to multiple internal repos of GitHub with read write. So
Yeah, I
yeah,
think
it's
a mitigating factor here is the fact that the secrets leaked are the organizational secrets. So, like, you do have to have set up some of those org secrets in order for them to leak, and you don't get access to the
yeah.
repo secrets. Oh, or, personal secrets, of course. You get your own for that. But it is more or less like you're going to be leaking those organizational ones that get added to every repository. So like it is a mitigating factor, but not necessarily that important. Like there definitely are important secrets that are stored as organizational secrets too. Uh,
Yeah, mainly what that's going to change is like who would be targeted with this sort of attack. It's going to be oriented more towards like enterprise and stuff like that at that point, instead of like individual, like indie
yeah,
projects or whatever.
yeah, but I like this vault. I thought it was kind of neat just seeing it abused. One, as you said, the security aspect. Seeing a security functionality get abused for a security issue. It's always just fun to see. Um, you know, kind of hate it, but also it is fun to see things abused that way. And also just the fact that it is kind of a logical thing. Code spaces are like they need certain environment variables, things should be passed in there. It makes sense to kind of have these sort of secrets. It's just the way this gets exposed is maybe a little bit unexpected, a little bit non-intuitive, that a random person can get access to one of your, or basically become part of collaborator inside of your organization, thus gaining access to all the organizational secrets. Like it is a little bit non-intuitive on in that sense, uh, but definitely a cool vault.
What did you mean by like kind of hate it? Sorry, I just
Well, it's a security issue. I mean, I don't want to promote and say, yeah, I love seeing everything being vulnerable.
oh, I see. Okay.
So,
uh,
like, hate to see it in
fair
that
enough.
sense, but as somebody who does the vault research, I like seeing it, but like, it's not good for everybody else.
Yeah, I get you. Especially those sorts of web issues in GitHub where it can affect everybody. Yeah. Um, fair enough. I just wanted some clarification on that. All right. So for our last vulnerability, or rather multiple vulnerabilities, we have a CorePlague, which is some vulnerabilities in Jenkins server, which I'll let Z get into.
Yeah, and there's like I said, a couple vulns here, but they really start from the same place. And this is mitigated by the fact there is a little bit of a process to hit this XSS, but in theory, you're able to hit not quite any Jenkins server, but you're able to hit like multiple victims with just this one input. And that's because of the Jenkins Update Center. So, you run your Jenkins server, you can look at available plugins and such to see, hey, what's out there, what can I install, what can I do with it. So you can access that either through your Jenkins server and get like a list of available plugins, or you can access it through like the want to say it's like update.jenkins.io or something. Basically, they have their own domain that you can go and look at specific plugins also. And so what they found here was that a malicious plugin, if it gets added, can have basically malicious metadata. Specifically, every plugin needs to specify what the required core version of Jenkins is to run the plugin. And that value is effectively just read out of it's in a metadata file, but effectively completely attacker controlled. It's just read right out of that file and reflected into a couple places without any sort of sanitization. Actually getting an update registered, so your update, in this case, for it to appear in the update center, needs to be in the artifact registry, which does have a process on. They talk about the initial process here of, you write your plugin, you submit a PR to Jenkins team, they'll review and approve it, at which point they'll create this Jenkins your plugin repository, giving you write access to it and write access to the artifact or artifact registry itself. With your first release, there is a bit of a approval process that goes through. They mentioned that it is just a procedural process. They don't really go into the details of what's actually checked there, but after that first one, according to the authors here, you can update your plugin as much as you want, including changing it to be something more malicious. So you'd have to kind of go through this longer process, but once you are approved and have kind of a plugin on there, then you can kind of hit this vulnerability. which again is uploading malicious metadata information for the file, with this core version being an XSS payload. Fairly straightforward payload. I think they just use like the image source on air. They just use this on air value as their source. Like it's not a complex XSS at all. I thought what was interesting here was just how deep you kind of had to go into the process to make that input. And so the two places that this gets reflected, one, as I mentioned, is on the update, like Jenkins IO page. When you access the actual plugin, it'll indicate, requires Jenkins, whatever version. And that is where the XSS gets reflected in there. And you can basically attack anybody that visits that page. You are only getting the XSS on the updates Jenkins IO domain and not the actual Jenkins server. So it's a little bit less useful there. I couldn't actually tell you what you could get on that domain, but I'm assuming it's not a ton because I believe that's mostly just for downloading the plugins and such. But the other place where it can show up is on the Jenkins server itself. When it's listing the plugins, if a plugin has a required version that's greater than the server's version, it'll issue this little warning saying like, hey, this requires a newer version, and it'll reflect the version into that warning, which then gets reflected onto the page again without any sanitization, giving an XSS on the Jenkins server itself. That sounds a lot more powerful. The problem is Jenkins does a little bit of filtering to say, basically generates like a bunch of JSON files containing all of the available plugins for each version. And in theory, it shouldn't even show those that have a version that is greater than the Jenkins server. It's just going to filter them out right at the beginning. It's never even going to see it. So you can't just go and add like version 1 million, say that's your required version, have everything reflect this. Cross-site scripting. They kind of do this. They call it their tiering or whatever. Site tiering mechanism. It does that, so that does limit the amount of instances that can be hit. The tiering only goes back so far. It only generates these JSON files. They mentioned back about 400 days, simplifying the process. They don't go into detail about how exactly that process works, if it's like X number of versions back or whatever. But at the present, if your version is older than the oldest kind of list that they maintain, you'll just be showing the oldest list they maintain, and that is the case where you can end up having this error show up. Effectively, if you have a version that's too old, so older than 400 days at the time of writing at least, I'm not sure if that's a rolling window. I'm kind of hoping it is, and the way that they talk about it, it feels like that's a rolling window, so like they only maintain the last, say, 100 versions or something. I'm not entirely sure about that, but the way they talk about it makes it sound like that's a rolling thing, so it's not like, in 100 days, it's going to be 500 days old or something. But anyway, those older than the 400-day mark, older than that oldest version, those can end up showing this error as it pulls down the updates and see some that are for the oldest maintained list version. Thus, they can still get the XSS on unupdated Jenkins. And then getting RC, once you have XSS on the Jenkins server, it was opposed to the scripts endpoint. Literally, I mean, Jenkins runs code. It's what it's supposed to do. I'm not surprised that they could trivially take it to code execution once they had XSS. There really wasn't much to it. The main thing I thought that was interesting here was really just how deep they kind of had to go to get this input. Being that's inside of, I guess I didn't talk too much. I just said it's part of this metadata, but you'll compile up your plugin that you, or like your artifact that you'll upload. The HPI file ends up being a zip file. Inside of that, you've got the metadata as its own little file inside of there. This manifest file. So, I mean, you had to think about the inputs a little bit. It's just one of those, it gets a bit more of a lateral thinking source on finding this input. So I thought that was kind of neat. But yeah, the XSS itself isn't too straightforward, and it is mitigated by the fact that most versions aren't going to show plugins for newer versions of Jenkins. So if you're keeping your Jenkins updated, you're never even going to see this error with the issue.
Yeah, something else I thought I'd give a quick shout out to is towards the bottom of the post. They have this little section about bringing the malicious plugin to the front. There's not really a vulnerability there, but they just talk about how they could potentially try to get their attack more widespread. And basically, that's just because as a file gets referenced whenever like a Jenkins admin tries to search for a plugin and access the plugin list, as part of the processing, it'll go through like the plugins and the lists and do a check on the plugin's required core. Um, and or sorry, yes. Let me jump back a bit. So yeah, basically what they were abusing there was just like the metadata. So it would search for like the metadata, see if there were keywords that would match your search terms, stuff like that. So basically like tag bombing, nothing too crazy, but I thought it was a little bit interesting in the context of like a vulnerability or attack, like exploit scenario. I thought that was a pretty cool way of leveraging it. So I thought I'd give that a quick shout out. It is there. I'm not going to go into it too much. But yeah.
Yeah,
So
I mean, it's there, but I don't know. I feel like the restriction just not even getting displayed at all feels like a pretty significant mitigating factor in general.
that's fair. Yeah. All right. So we'll get into the shoutouts. I'll let Z get into them. We have 2 of them this week, and then we'll wrap up the show.
Yeah, I had 2 things to talk about here. One is Firefly, new. Well, I guess I missed it by a bit. Looks like they published this in February. Or no, well, I guess it can't be October because that's 2023. But for Firefly, black box web fuzzer. I thought it seemed kind of interesting. At a glance, I was looking at this and I saw they talk about their different scanning, their verification process a little bit for doing web fuzzing. It's an area I have a sort of passing interest in because it is a challenging area. Like binary fuzzing, we have a really nice fuzzing kind of infrastructure. People understand fuzzing and like it goes deep, it goes hard. Web fuzzing, there are issues when like a lot of it just ends up being replay this word list, maybe add a mutation on top of that, do these mutations, but ultimately it just does that, and then you don't have a really good means of validating if something worthwhile happened. And so when I saw them talking about doing this different scan and so they would, and their verification process where they make a sane request that isn't doing anything, then they take a look at the difference there, trying to process it. Some of it sounded interesting. Looking a bit deeper, I'm not so sure it is actually that interesting. It does seem like a lot of their checks are similar to what you see with like FFUF or something like that. It doesn't necessarily seem that interesting, but at a glance, it did seem like they had some more interesting ideas here. So I wanted to shout this out, at least as something to check out. I haven't used it myself. Seems a little bit interesting. And they also linked off to backslash powered scanner, which was an older post by James Kettle, which sorry, I thought that was the link to it, and it's like I opened the wrong thing. There we go. Which also is kind of apparently interesting post here about doing some of the scanning and trying to find the web fuzzing issue. So he wrote this back in 2016. I don't remember ever having actually seen it, so I want to check out the talk he has with this also. But it's one of those things that web fuzzing has challenges, so I saw some new research and figured maybe someone else be interested in taking a look at this also. Also bring up the source code. Source code goes a little bit deeper into, the functionality and some of the options there. Some of it's going to be pretty similar to FFUF if you've used that, but I don't know. There are a few interesting things here, so wanted to shout it out. And last shout out, server-side prototype pollution gadgets for EJS. So EJS itself generally is protecting all of the objects they create, so you can't do prototype pollution on it. But if you have pollution on something that's going into or being passed into EJS, then they just have a technique for getting RC from that, which is the effectively using escape function to get your shell code, or well, pop your shell, I guess. Yeah, it's one of those techniques, kind of like last week where I gave a shout out to just an exploitation technique. If you end up in the right scenario, this is another one of those. If you end up in this scenario, it's great. It's nice to know, but that's about all there is to it. Just here's the trick you can use when you end up in this scenario.
All right, so with that said, that's all the topics that we have for this week. So as always, thank you goes out to everyone who tuned in. As per usual, recent episodes can be found on Twitch, and all of them are up on Spotify, Apple Podcasts, YouTube, and more. Discord and Twitter links are down below or in the chat, and we'll be back tomorrow at 7 p.m. Eastern, 4 p.m. Pacific for the binary topics, and we'll see you then.